Now we have learned how to work with radical expressions. We will see how we can use what we learned in manipulating algebraic expressions and calculations involving radical expressions. Okay, let's see. Here we use the distributive property with radicals. Let's start with A. As we did before, when we multiply a binomial by a term, we multiply this by this, and radical 11 by radical 2. So this is the next step. Now, 5 times radical 11, there is nothing we can do about that, minus, here we can use one of the properties, okay? So it's radical 2 times 11. So it's radical 22. 5 times 11, there is nothing to be done about it. 22, let's see if there is something we can do about it. Simplify it more. 22 is 2 times 10, and 10 is 2 times 5, so 22 is 4 times 5. Radical 4 equals 2, so this becomes radical 4 times 5. Radical 4 comes out as 2, so this is 5 radical 11 minus 2 radical 5. B. So 7 times radical 54, 7 times minus radical 24. 54 is 6 times 9. The 9 comes out as 3. Radical 9 is 3. So you have 7 times 3, and radical 6 stays under the radical sign, minus 7 times the 4 comes out as 2. Radical 4 is 2, and 6 is stuck under the radical sign. So this is 7 times 3 is 21, minus 7 times 2, and now these can be, because we have the same radical term, okay, so 21 radical 6 minus 14 radical 6, so this is 7 radical 6. Multiplying binomial involving radical expressions. Okay, as we learned before, it's called the FOIL method. We simply multiply this by this by this, and then this by this by this, as we have done before, but now we have radicals to work with. So 2 times 1, 2 times radical 5, 3 times radical 3 times 1, and radical 3 times radical 5 is radical 3 times 5, which is radical 15. This is radical 15. So this cannot be simplified any further. The 2 cannot be added to any other term. Radical 5, there is nothing we can do about the radical 5. And radical 3, same. Over here, the problem is we have radical 3 times radical 5. So we cannot make use of that fact to simplify this further. All right. B. Let's do B first. Now remember this. A squared minus B squared is A plus B times A minus B. So we have to look at this from both directions. This equals this, this equals this. So this is the right side of what we have over here. If you identify A as 4 and B as radical 5. Okay, remember the plus and the minus have nothing to do with A and B. Okay, A is 4 and B is radical 5, regardless of the plus or the minus. So A squared is 4 squared minus B squared, so radical 5 squared. So this is 16 minus 5, which is 11. This, see, what we have here is A minus B squared. Of course, this is completely different from A squared minus B squared, which we used over here. This, as we know, is A squared, as we know and as we should memorize, 2AB plus B squared. Again, A is radical 13, B is 2. So, A squared, radical 13 squared, the radical cancels the square, or the square and the radical cancel out, minus 2 times A, which is radical 13, times B, which is 2. Okay? Plus, remember this is a plus always, even if this is minus, plus 2 squared, B squared, which is 4. Now what we have here is 13 plus 4 is 17, minus 2 times 2 is minus 4, radical 13. Multiplying binomials, again with radicals. Now we have the cubic root. 4 times 4 is 16. All right, okay. I just noticed something here. It's the same trick as before. You have A plus B, A minus B. So this is A squared minus B squared. This is A, and this is B. Okay, regardless of the sign. So this is A squared, 4 squared, minus B squared. Okay, this is B squared. Okay, so you can leave it like this, minus cubic root of 49, and this cannot be simplified. Okay, because remember 3 to the power 3 is 27, so it's less than 49, and 4 to the power 3 is 64, greater than 29. So the cubic root of 49 is a fraction between 3 and 4, 3 point something. All right. Again, A plus B A minus B. A in this case is radical R, and B is radical S. So A squared, which is radical R squared, minus B squared, is radical S squared. So this is radical and square, they cancel out each other. So there is no square here. In both cases, the radical and the square cancel out. Rationalizing a denominator. A common way of standardizing the form of a radical expression is to have the denominator contain no radicals. The process of removing radicals from a denominator so that the denominator contains only rational numbers is called rationalizing the denominator. This is done by multiplying by a form of 1. We don't like to have radicals in the denominator. For instance, if you have 3 over radical 2, remember you cannot change it. So what we do is we multiply by 1. So this is a form of 1, all right? And then we would have 3 radical 2. Radical 2 times radical 2 is radical 2 squared. So now we have a rational number in the denominator. Okay? The reason why we do this is kind of standardizing it so that it can be compared to other rational expressions involving radicals. Plus, it's easier for computation. Also, I think it's easier for your mental approximation of the value of the number. Okay, you have a better idea how big or how small is the number when you know you're dividing by a whole number like 2. All right. 5 over radical 11 multiply by 1. Just like what I did before. So you have multiplying in numerators, you get this, and multiplying denominators, radical 11 times radical 11 is radical 11 squared, and that is 11. The radical and the square cancel out each other. This, again, a square root. This is 5 times, okay, and that's the 5th root. So we want to get rid of the radical term in the denominator. We multiply by 1. Then radical 6 times radical 5 is radical 6 times 5, which is radical 30. And radical 5 times radical 5 is 5. 5 cancels 5, and this is the final answer. Rationalize. Again, before you start multiplying by radical 18, you try to see if you multiply by a simpler number. Okay, so what we do, we simplify this first. Okay, 18 is 2 times 9. Now the idea is 9 comes out. Okay, radical 9 is 3. So it turns out it's not the radical 18 that we need to get rid of. It's the radical 2. Okay, that's the idea. So what we do is we multiply the resulting number by 1. Okay, and here we have minus 8 radical 2 divided by 3 times radical 2 times radical 2 is 2. So this is equal to, cancel 8 divided by 2 is 4. So we have 4 radical 2 over 3. Okay. So this is equal to, again, the minus is totally outside the radical, so it doesn't affect it. We just carry it along through the calculation. Radical 8 is 2 times 4. Okay, 8 is 2 times 4. Radical 4 is 2, and you are left with 2 under the radical sign. 45 is 3 times 15. Okay, so you have radical 3 times 15. Now, 15 itself is 3 times 5, so you have 9 times 5. Okay, so 45 equals 9 times 5. The 9 comes out as a 3, comes out from under the radical sign. So you have 3 radical 5. So what we need to get rid of is the radical 5. So we multiply by radical 5 over radical 5. So this is minus 2 radical 5 times radical 2 is radical 10 divided by radical 5 times radical 5 is 5 times 3 is 15. Simplify each radical. Radical 200k to the power 6 over radical y to the power 7. Now, the 200 equals, okay, the radical is a square root in all these cases. So we want a square under the square root to get rid of the square, or to bring out the number from under the square root. What I mean by that, you have radical 9, so this is radical 3 square, so that you can take the 3 from under the radical sign. All right, 200 is 2 times 100. The 100 is 10 squared, so that's why we need that. So this is equal, the 100 comes out as 10, because 100 is 10 squared. So you have 10. K to the power 6 divided by 2, because it's square root. So it's k comes out k to the power 3. And you're left with 2 under the radical sign. Okay. Y to the power 7 is y to the power 6 times y. Okay, and radical means 1 over 2. So this is equal y to the power 6 over 2, y to the power 1 over 2. So y to the power 6 over 2 is y3, so we get rid of the radical. And y to the power 1 over 2 is radical y. So you are left with y under the radical in the denominator. Now we need to get rid of that. So we multiply by 1 times radical y over radical y. Okay, this is the term we need to get rid of, so there is no need to worry about this. Now, radical y times radical y is y. Okay, and radical y, radical 2 get under the same radical sign. So this is equal 10 k cubed radical 2y. This gives us y, and we have y cubed here, so this is y to the power 4. Cubic root of 15 over cubic root of 32. First, separate the numerator from the denominator. 32 is 4 times 8. Okay, here we make use of the 8, not the 4. Okay, if it were square root, then the 4 comes out as 2, because you have radical 4 equals 2. But what we have is a cubic root. For a cubic root, the 8, because 8 is equal 2 to the power 3. So radical 8 equals cubic root, sorry. Okay, so we need the 8. So this comes 2. Okay, radical cubic root of 15 stays the same. Now we need to get rid of this. Rationalizing means get rid of that. We should multiply by the cubic root of 4. There is a mistake here. This is a cubic root of 4. Cubic root of 4. Actually, no, it's the because the cubic root doesn't the cubic root of 2, actually, yes, the cubic root of 2, because we want under the cubic root to have 8, so that you have a cubic root of 8 equals 2. So we need one more 2. So this is the reason we multiply by the cubic root of 2. So this is equal cubic root of 15 times the cubic root of 2. This is the cubic root of 15 times 2. In the denominator, we have 2, and cubic root of 4 times cubic root of 2 equals cubic root of 2 times 4. Right? And remember, 8 is 2 to the power 3. So the cubic root and the cubic power cancel out, and in the denominator we have 2. So now this is the cubic root of 30. 2 times 2 is 4. All right, higher roots. First, we separate the denominator and the numerator. To get rid of this, we need w to be raised to the power 4. Okay? To get rid of fourth root, you need something to be raised to the power 4. W is already raised to the power 2. So we need another w to the power 2 under the fourth root. So this is the one we are multiplying by. So here what we have, fourth root of 6yw squared. And here you have the fourth root of w to the power 4. So this is fourth root 6yw squared. Fourth root cancels the power 4. All right. This is a little bit tricky, but it's we have a very nice, very beautiful trick to get rid of the radical in the denominator. So denominator here has a binomial. It doesn't have a single radical term. It has a binomial that whose one of its terms is a radical. Here what we do is we use the trick that x we have here. Okay, x plus y times x minus y is x squared minus y squared. Okay, the squaring helps us get rid of the radical. So what we do is we multiply by what's called the conjugate. So if this is what we have in the denominator, we multiply by this. If it is the other way around, if this is what we have in the denominator, we multiply by this. So this and this are called conjugates. This is the conjugate of this, and this is the conjugate of that. So the trick is to multiply by the conjugate of the denominator. All right, so let me do this example here, since we already have it. So what we do here is again, it's a 1. Okay, we multiply by this. Okay, this is a 1. So here what we have, 3 times 1 minus 3 times radical 2. And here we have a squared minus b squared. b is radical 2. Radical 2 squared is 2. So here we have minus 1 in the denominator. Okay, so this is 3 minus 3 radical 2 over minus 1. So remember, the minus can go anywhere, and since dividing by 1 is like no denominator, this is what we have. So this is 3 radical 2 minus 3, or 3 into radical 2 minus 1. All right. This is the denominator. We multiply by its conjugate, but we have to do the same thing for the numerator. Basically, we are multiplying by 1. Then numerator becomes 4 times 2 plus 4 times radical 3. And this is a minus b times a plus b. A is 2 and b is radical 3. So a squared is 4 minus radical 3 squared is 3. Remember, the 2 doesn't have a square root. So that's why the square doesn't cancel out. So 2 squared is 4. Doesn't gets cancelled out. Whereas the radical 3, if you square it, you will have a 3. You don't square the 3. Again, here 4 minus 3, the denominator is 1. So this is simply this. Or, if you like, 4 into 2 plus radical 3. Again, the denominator here is a binomial where both terms are radical terms. We multiply by the conjugate. Since this is plus, the conjugate will have a minus in it. So, as we did before, 7 times radical 2. Okay, actually, we can keep the denominator as is. There is nothing we can do with the radical signs in the denominator. So, keep it like that. And here it's always the same, a squared minus b squared. So, radical 2 square is 2 minus. This is always minus, remember. One of them here is plus, the other minus, but the result is always minus. Remember this, a plus b, a minus b is a squared minus b squared. Okay, it's never plus. So, radical 3 squared, the radical cancels the square, so this is 7 radical 2 minus radical 13 over 2 minus 13 is minus 11. Bring the minus up, so this is 11 minus 7 into radical 2 minus radical 13. Now this minus can go over here, multiply it in, so that what we have is 7 radical 13 minus radical 2. Okay? Minus times minus becomes a plus. And minus times plus becomes minus. All right. Again, the conjugate of this is this. So we multiply by 1. Same as up. Okay, there is a huge difference between these two here. Both of them are plus. Okay, so radical 3 times radical 2 is radical 2 times 3 plus radical 3 times radical 7 is radical 3 times 7 plus radical 5 times radical 2 is radical 5 times 2 plus radical 5 times radical 7 is radical 5 times 7. In the denominator, it's much easier because we have a minus b times a plus b. So this is 2 minus 7. What we have is minus 5 radical 6 plus radical 21. 21 is 3 times 7, so it's not useful. Radical 10 again stays the same, and radical 35, it's 5 times 7, so it doesn't help. And the minus can go up here instead of here. Multiply by the conjugate. Okay, so we have 2 radical k minus radical z. There is nothing that can be done here. And here again we have a squared radical k squared minus b squared radical z squared. So z. Okay, there is nothing else to be done. Finally, I think this is the last example. Okay. Write each quotient in lowest terms. So here what we do is we take the common factor, greatest common factor of 24 and 36. That is 12. Now 12 is 3 times 4 and 16 is 4 times 4. So 1, 4 cancels out and we're left with 3, 2 minus 3 radical 7 over 4 in the denominator. Now over here we have 32 is 2 times 16. This is a radical square root, so the 16 comes out as 4. Okay, radical 16 is 4. So we have, this is 6x, 2x plus 4, that's the radical 16, and radical x squared is also x. Okay, and this is stuck under the radical sign. Now 6 in the denominator is 3 times 2. So a common factor over here. Okay, and here 2 times 2 is 4. So what we have is 2x plus 2x times times 2 radical 2 in the denominator over 3 times 2x. Okay, so this is this. You can take 2x common in the denominator. So this is 2x into 1 comes from this plus 2 radical 2 comes from this, divided by 3 times 2x. Now this goes with this, and simplified form is 1 plus 2 radical 2 over 3. So it turns out there is no x in this expression.